This lecture is titled Ingredients of a Mathematical Model. By the end of the lecture, you ought to be able to explain why economists use models, discuss the different types of models used, define a mathematical model, and identify variables, constants, and parameters in a mathematical model. Recall, in their role as scientists, economists present theories or hypotheses to explain economic phenomena, those relationships between different variables that we observe around us. And just as an FYI, theories and hypotheses are just systems of ideas intended to explain economic phenomena, facts, and events. And economists develop these theories and test them by following the scientific method. But this world is pretty complex. And because of this, economists, just like biologists or engineers, rely on models, which are just simple descriptions of the system we're interested in. These models are used for explaining something, forecasting, i.e. predicting, and in some cases, for policy prescriptions. By using assumptions and focusing on the most important aspects of the world around us, models just are simple versions of reality. So, models have to balance realism but manageability. And you've seen models before. Biochemists and medical students use anatomical models when studying morphology. Engineers use design models to explain processes. Chemists use molecular models to study molecular processes. You use a roadmap to get from point A to point B. And economists use models to study economic behavior. Now, to an economist, in our broad discipline, remember, we study everything from purchasing decisions to sports to crime, poverty alleviation policies, so on and so forth. So an economic model is just a theoretical framework that helps us analyze any real-world situation. And a model can take a variety of forms. A model can be verbal or logical, like Adam Smith's invisible hand paradigm. The invisible hand is just a model teaching us that prices in a market are the mechanism or the guide which ensures equilibrium and general welfare in the economy. We can have a visual or geometric model, like equilibrium occurring at the intersection of supply and demand curves in a market, or the circular flow diagram that you learn about first thing in your 105 courses. Models can be mathematical, and mathematical models can take one of two forms. It can be algebraic. Algebraic models just make use of equations and symbols to explicitly show relationships between different variables. For example, supply and demand equations or population growth models. And another type of mathematical model is econometric or empirical models. And these are just algebraic models that account for data. So again, why do we use math? The science of econ reached a turning point in the 18th century when we had economists like David Hume's Political Discourses and Adam Smith's Wealth of Nations. So at the time, economic arguments were largely philosophical, but we wanted to be able to formalize and develop them into complex theories. What this meant is that we needed to express these increasingly complex ideas and relationships in a very straightforward, explicit manner. So economists began to use the language of math, symbols, equations, simple diagrams, and graphs to explain theories. So we use math because it forces us to be explicit, precise, and concise at every single stage of our reasoning. And math is a language, it's logical, and it's globally accepted. Math allows us to be more realistic when we're modeling economic behavior. So many of you have seen the model of supply and demand for a particular market. But that's just one market. It's known as partial equilibrium. But we know that in the real world, many markets exist, and they all interact with each other. Math allows us to move forward and study multiple things at one time. And finally, math allows us to transform the story, the idea we want to tell about economic behavior, to a testable model. With equations and data, we can verify if our stories make sense. So again, a mathematical model. A mathematical model is just a formulation or an equation. It expresses the essential features of a physical system, an economy, for example, or a process in math terms. So instead of using letters and words, sentences, we just use symbols and equations. So in a very general sense, a mathematical model is just represented by a set of equations that relate variables we're interested in a certain way. So for example, we might say, listen, when the price of a good rises, the quantity demanded of that good falls. In math terms, we can write it out like the equation shown. Q sub D, which represents quantity demanded, is equal to 100 minus 10 times P, where P is price. So we all need to know how to read a mathematical model. The first part of mathematical model is going to have variables, also known as unknowns. And these are things that can vary with magnitude. Think price, quantity, income, things like that. And we usually represent variables by letters, X, Y most notably, and Greek letters. We also have constants, and constants are those things that do not vary with magnitude. So for example, specified number or letter, 3, pi, a. Constants are those things that are not attached to variables. This is contrast to coefficients or parameters. We're going to use coefficients and parameters interchangeably in this course. Coefficients are just simply those constants that are attached to variables. Let's look at an equation. Here's our demand equation from before. We have Q sub D is equal to 100 minus 10P. Let's figure out where the variable, constant, coefficients are. So variables, those things that can vary with magnitude, and those are represented by letters. In the equation below, the variables are Q sub D and P. They can change. When P is equal to 0, QD equals 100. When P equals 1, QD is equal to 90, so on and so forth. How about those constants? Constants are those things, again, that do not vary with magnitude. They're not attached to variables. In this example, Q sub D equals 100 minus 10P. The constant in this case is 100. And then coefficients are those constants that are attached to variables. So in our equation here, that would be 10. And mathematical models are made up of expressions, equations, identities, and functions. So an expression is just a mathematical phrase using constants, variables, and operations like plus, minus, subtraction, and division symbols. So an example of an expression is x squared plus 4 plus 10. Now an equation is a mathematical statement saying two algebraic expressions are equal to one another. So for example, x squared plus 4 plus 10 is equal to 5x minus 2. And then finally we have a function. And we're going to talk about functions in more detail later on, but just to give you a heads up of what it is. A function is a special type of equation. It just expresses a relationship between a dependent variable and one or more independent variables. So in this example, we have a function, y equals f of x is equal to x squared plus 4 plus 10. The dependent variable in this case is that y. It depends on the value of x. So the independent variable is x. So let's summarize what we've learned with an example. We know that models can come in a variety of forms. Let's take the environmental Kuznets hypothesis. In words, this hypothesis states that as income rises, pollution rises and then begins to fall. We can have a visual model of this. This is the environmental Kuznets curve, or the EKC. So reading this graph, we see some sort of emissions per capita or per person on the y-axis. And we have GNP per capita, which is just a measure of income, so income per person on the x-axis. And we see this rising in the beginning of pollution per person, and then this eventual gradual fall. We can also state this hypothesis with math. We can say that emissions per person, E over P, is equal to some constant plus some coefficient times income per capita, plus another coefficient times income per capita squared. All of this will become much more clear when we talk about equations. And we can have an econometric model, which we're not going to get into in the math portion, but this is what one would typically look like. The only difference being that the second one, the econometric model, when compared to the math model, just takes into account data.